Hey guys, today we're going to be working on section 8.1, identifying quadratic functions. This whole unit is focused on quadratic functions. So in this section we're going to look at what are some of the identifying characteristics of a quadratic function. At any point in this video, definitely pause it to make sure you're taking notes as you would in class if I was there. Alright. So definitely write how can you tell from a table of values if a function is a quadratic or not. You're going to want to know that this is the question I'm asking for this information. So in this first table, if we are looking at this, we notice that each of these x values is added by 1. So we have this constant change that's happening here. And now if we look at this, we notice that the pattern is adding 3 each time, right? Negative 4 plus 3 is negative 1, negative 1 plus 3 is 2, and so on. So if you remember back to linear functions in chapter 4, it was obvious a table of values was linear if this change in the x was constant and the change in the y is constant. So this is actually a linear example, not a quadratic. Just tying in something that we've learned before. So then let's see what happens with these. This will be a quadratic example. So going from here to here, we have a constant change in our x, and it's increasing by 2 each time. Over here, let's see what's happening. From 8 to 2, we went down by 6. From 2 to 0, we went down by 2. From 0 to 2, we went up by 2. And from 2 to 8, we went up by 6. So when we talked about linear functions, back to this one, it was important to remember that we call this the first difference. And when we had those first differences in the x values consistent and the first difference in the y values being consistent, we knew that was the definition of a linear function. So this is the same thing. I'm going to call this also the first difference, as well as this is also the first difference. Now, we're actually going to look at the second difference to decide if this is quadratic or not. So from negative 6 to negative 2, we increased by 4. Right? Negative 6 plus 4 is negative 2. And from negative 2 to 2, we increased by 4 again. And then from 2 to 6, we also increased by 4. So now we notice that these second differences are consistent. So this is your second difference. So when your second difference is consistent, that is a quadratic function. So linear functions, first difference is consistent in the y values. In a quadratic function, you look at the second difference to be consistent for the y values. Notice on the x values for all of these, whether linear or quadratic, the x values have a consistent change. So we really start to look at the y values to determine what kind of function it is. Alright, here we go. Example 1. I definitely would like you to write this as example 1 and that you're going to graph this equation. We're going to make a table of values and then graph this. And if you'll notice, my graph goes out to 5 and negative 5 and negative 6 and 6. If you want to do a graph that goes out to 5 on each side, that's fine. Alright, so starting out, we're going to do an x and a y column, and then this is going to be where we plug in. So starting out with these table of values, I will be providing you with your x values. You guys will be asked to plug in and find the y. So starting out, we're going to do negative 2, negative 1, 0, 1, and 2. So here is our function, y equals 2x squared. This is a quadratic function, by the way. And we're going to plug in each value and get a y value. Y equals 2 times negative 2 squared. Y equals 2 times negative 1 squared. Y equals 2 times 0 squared. Y equals 2 times 1 squared. And y equals 2 times positive 2 squared. So just notice how I'm taking this function and replacing x each time with this x value. And now we're going to evaluate this and figure out our y values. It's very important that when you plug in for x also to use parentheses. So negative 2 squared is positive 4. Positive 4 times 2 is 8. You're welcome to use a calculator on this part if you aren't already. Negative 1 times 2, negative 1 to the second power is 1 times 2 is 2. 0 to the second power is 0 times 2 is 0. Order of operations, right? I'm doing my exponents first, PEMDAS, then I'm doing my multiplication. So exponents, then multiplication. 1 to the second power is 1 times 2 is 2. 2 to the second power is 4 times 2 is 8. So just working out those and getting your y values. So obviously we're only going to graph these 3 points because I don't have a y-axis going out to 8, and that's okay. As long as you can get 3 good points, we'll be fine. So this first point is 0, 0. This top point is negative 1, 2. And this bottom point is 1, 2. Alright, so we'll graph this first. Negative 1, 2. So negative 1 on the x-axis and 2 on the y. Put a point. 0, 0. We know that's the origin. Okay, and 1, 2. 1 on the x and up 2 on the y. Now when we draw a parabola, hopefully I can do a good job here, it is not a sharp line coming to a point like this. You would not draw it like that. It is a curve. So you want to make that curve look correct. Okay? And that's the graph. Table of values, graph. That's it. Make sure you have graph and table.